Ladies and gentlemen, my name is Nicolaou. I will speak in English so we don't confuse the terms between Greek and English. I am a senior director in Bell Laboratories who has been in the heart of innovations since the beginning of telecommunications. Bell Labs is now an integral part of Nokia, and we are pushing the envelope forward. I am not here to talk to you about the immediate future of technology. I would like to talk to you about the future of technology. From the beginning of the human race, economists have been predicting that we will be extinct by our own growth. The resources of the planet are not enough to sustain us. The only reason that we have managed to survive so far is because of technological revolutions. At this moment, as previous speakers have said, we are reaching a moment where we must invent new networks and realize a new technological revolution which will be 100 times more capable, 1,000 times faster, and will have much faster and reduced latencies. Today's networks are not designed for this revolution. They're designed for the needs that we had so far, to download a file where we don't mind if it takes a few seconds to be downloaded, to hear a song, and we as humans cannot perceive latencies over 10 or 100 milliseconds. However, now, in order for us to connect the right devices with the IoT revolution coming and the enablement of virtual RAN, cloud RAN, and 5G, we will need much faster networks. However, we will be hit by 3 barriers. The first barrier is physics. Signals cannot travel faster than the speed of light. Mathematics, we have the Shannon limit, which has been a limit. It's a real limit that we cannot exceed. And of course, the economics. If we had infinite money, then we would invest immediately and do everything at the same time. What is absolutely clear is that we need to re-architect the networks from the ground up. Very quickly, just to try and learn from the past, as we moved from the agricultural to the first, second industrial revolutions, and then the scientific technical revolution where we learn how to process analog and digital signals, we moved to the information technology, and now we are at the time of automation. We must re-architect the network to be able to automate everything. We, as Bell Labs and as Nokia, believe that the future of the network must be a cloud, fully integrated network. In the short time that I have, I will try to quickly address 5 themes that are driving this need. I will go through the first 4 very quickly and touch on the 5th, which is more relevant to this conference. So these drivers are the rise of the machines with the IoT coming. It's well understood, it's already happening, that there is a revolution of devices coming to the network that want to communicate between them and with us. The emergence of the enterprise. The consumer has a specific disposable income. We cannot get infinite money out of the consumer, and therefore we must enable the right networks which will create the new business by focusing on the enterprise market. The move to the edge cloud, and the need to move to the edge cloud is very necessary in order to avoid the 3 limits that I said, especially the limits of the speed of light and the limits of latency. The evolution of cognitive operations, this means that we need better and more autonomous OSS systems. And finally, the confluence of networks, which is essentially integrating the networks to realize better performance, and also better economics. Let's start with the rise of the machines. As we started creating tools, then came smarter tools, and now we are starting to see little devices that are everywhere. Autonomous connected meters, the grids, the energy systems, drones, virtual reality. A lot of people are trying to connect intelligent systems into our sunglasses or our glasses so that as we walk through the world, we perceive in real time a new experience. It may take a few years, but it will come. All these will create a much, much higher demand for interactivity and a lot of signaling, a lot of new interactions. Therefore, we must create a network that is very cognitive and can do things faster than we can. The emergence of the enterprise, I believe, is a key strategic focus of our industry. We have served the consumer well with the creation of 3-play and 4-play, but now there are a lot of efficiencies that we can improve in the enterprises with truck systems or essentially the aviation industry. All of these new industries will require a new network, but when we enable this, there will be a lot of new benefits and a new revenue for us to realize. Let's talk now why we need to move the network to the edge. Up until now, we as humans can live with 100 milliseconds of delay, and 10 megabits per second are good enough for most of us. However, as we become more and more dependent on machines and we enable new systems and new networks, for example, virtual run and afterwards cloud run, autonomous vehicles are coming. Budweiser last week tested the first truck delivery automated in the US. High frequency trading, for example, these will need much lower latencies. The green line there is essentially the limit around 7 milliseconds where we can perceive as humans and our brain can process from thought to motor movement. Therefore, we need faster systems, and because of the limits, we need to push the network and the intelligence of the network closer to the edge. This chart gives a similar concept. So far, we have been operating in the left bottom quadrant. We could live with latencies less than 10 milliseconds and with speeds less than 10 megabits per second. However, with the new introduction of new video, as fancier video comes, 4K, 8K, virtual reality, we will of course require higher throughputs. But at the same time, as more intelligent systems and machines come to the network, we will require much faster latencies in the order of 10 milliseconds and below. Very quickly on the cognitive operations, this means that as networks will need to become more efficient and intelligent, also the operational systems will need to be re-engineered to be able to serve this kind of system. So far we have been dealing with 1, 2, or 3 networks. Now there will be thousands of networks because we will need to create individual virtual networks that will serve enterprise customers, and they will serve individual organizations, and we need to manage them separately. We will need to manage many micro services, and this will create a lot of interaction on the network. And now I will move to what is more relevant to you today, which is the next generation access network. And what we are seeing is that different networks, for example, DSL, cable networks, and wireless, have been developing at different rates. However, as we see, they are all converging on one limit of 10 gigabits per second. In the end, all these networks will come together, and we believe that we have to enable a new technology that very economically can serve all these needs together. As the networks so far have been developed in isolation and separately from each other, the future network will need to be converged and collapsed together, and at the same time move to the edge so it can enable all these new performance requirements that are being put on the network. At the same time, we will need to serve the IoT and the Internet of Things that is coming. Another fact of our industry is the fact that economies of scale matter. The bigger you are, the more integrated networks you have, the more services you can provide, then your free cash flow becomes better and your margins become better. This is why all over the world we have been seeing acquisitions. For example, in Germany, Vodafone bought KDG. In Spain, Vodafone bought Ono. Recently, and surprisingly, it was a big acquisition, BT bought Everything Everywhere. So as we see on this chart, we did a quick study, and it's easy to see that in order to realize better margins and free cash flow, one must consider consolidation, which will be inevitable. Let's go now to what is happening in Greece and a little bit to the next generation, which we expect right after the implementation of deeper fiber. We believe that this is driven by economics, and the traditional DSL networks have now started to be replaced by VDSL networks, and then we will push fiber closer and closer to the consumer, and in the end, all the way to the home. As we do this, the networks, the latencies become better, the speeds become faster, and at the same time, we must utilize this deep fiber to be able to enable networks of small cells, which will be realized by 5G, and at the same time, serve the macro so we can become more efficient in our delivery and cost economics. This chart very quickly, the red line shows that as we move up and push the deeper fiber into the network, the cost of delivery per megabyte goes dramatically lower. As we start from ADSL, where the cost of delivery was in the order of $10 per megabyte, now the new networks will become much more efficient, but at the same time, there's more megabytes and gigabytes required by the end user. And finally, as I mentioned, we believe that a new edge node must be created to realize the economics, which will be able to handle in a software programmable way, because the clock speeds are the same, the needs are the same. So as Bell Labs, we are now working on a new innovation called the Future Remote, where will be a single programmable device that will enable this new transformation of the edge. Thank you very much.